Hi guys, welcome to another video. Okay, so we've got this matrix right here. And you know what we're going to do? We're going to find the inverse. Now I'd encourage you to pause and maybe do it for yourself. See if you can do it in your head. And when you do it, I want you to forget everything you just did. Now you might think this is easy, but I'm going to show you a new method. Well, it's not new, but I'm going to show you a method that's going to change the way you think about inverting matrices. In fact, you will never, ever invert a matrix the same way after seeing this method. So let's get into it. Firstly, we're going to recall what an eigenvector is. So we've got this right here, ax equals lambda x, and now A is our matrix. It can be any matrix, except it has to be a square matrix. And lambda is just a constant. So we've got our vector x here, and what happens is when we multiply this x by our matrix A, we just get a multiple of x. So when x is a vector that has this property, we can have this formula. So let's go and subtract lambda x from both sides. Okay, now let's just factor out x. Now we include lambda I instead of just lambda here because if we had just had a minus lambda, we don't have a matrix. And recall that because ix equals x, then lambda ix equals lambda x. So, yeah. Okay, so now we sub in our matrices A and obviously I. And we're just going to combine them into one singular matrix. Now let's assume that x is non-zero because that'd be boring. And it's not zero. But if we multiply both sides of this equation by the inverse of the matrix on the left of x, then we're left with x equals 0. Because remember that this 0 represents the zero matrix, and a matrix times a zero matrix is the zero matrix. But x is not 0. And the consequence of this is that this matrix cannot be invertible, because if it was, then we get this boring 0 answer. So we need to make sure that the matrix is not invertible. And you know when it's not invertible? When the determinant equals 0. And for a 2 by 2 matrix, this is easy enough. You just multiply the diagonals and subtract the other diagonal. And we're left with this. Now with a bit of expanding and combining like terms, we end up with this. Now this is called the characteristic equation of our matrix A. And at this point, you might be wondering, okay, Ryan, you told me that we were going to find the inverse of a matrix, and you're doing this. And I promise you, we're about to get to that, but I need you to know how to find the characteristic equation of a matrix to find its inverse. And here is why. New tech dropped. Cayley-Hamilton theorem. This says that a matrix satisfies its own characteristic equation. So, pretty much, those lambdas in the equation, just replace them with A, yeah? And we get something that works. And why, you ask? And I'd advise you not to ask questions. So let's replace lambdas with A, like this. And here's where the cool part comes in. We know what A is. Obviously, it's given to us at the start. And if we know what A is, we know what A squared is. So how can we use this fact to find A inverse? Well, let's simply multiply everything by A inverse on the left side and see what happens. Don't mind the red. I thought it'd look cool. It kind of doesn't. Anyways, forget that. So pretty much, we have A minus 1 times A squared. That reduces to A. We have A minus 1A. We know by definition this equals I. We've got A minus 1I, which equals A minus 1. And we've got A minus 1, 0, which is just 0. So now we have an equation with only one unknown, which happens to be A inverse. So we can rearrange this equation in terms of A inverse like this. Now we just multiply both sides with a scalar 1 on 10. And we get this. And let's sub in the actual matrices now. Let's combine the matrices. And there you go. That's our inverse. Okay, you can check this in your calculator or your good old noggin. But the fact remains, after knowing this method, you will never invert a matrix the same way. Keep in mind that just like my previous inverting matrices video, you can do this for any n by n matrix. So I hope that I spread some magic. And as always, it'd be appreciated if you liked, subscribe, comment, whatever, because without your support, then I wouldn't be able to spread my gate-kept knowledge, because we all know that math shouldn't be gate-kept. Please? Pretty please? Yeah, okay, I'll see you for the next video.